Here's a problem about families of functions. So we're given the graph of y equals x e to the minus bx, or the equation. Part A says sketch the graphs of y equal x e to the minus bx for 4 different values of b. Describe the graphical significance of b. So what I do is I go into my y equals menu, and I have listed all x e to the minus 1x, x e to the minus 2x. So b is 1, 2, 3, 4. The negative sign was in the original equation, as you can see right here. Okay, and I did the little bubbles here so you can see which one's graph. So the first one that's going to graph is b is 1, second one b is 2, etc. So here's the window I'm on, minus 1 to 2.5, minus 0.5 to 0.5, and I graph. So here's where b is 1. Here's where b is 2. Notice that it's beneath the original graph. It's kind of shrinking in towards this direction. Let's see if that works with b is 3. Here it comes right there, just underneath where b is 2. And b is 4. Should be underneath here if the pattern goes. There it is. There it is. All right. Now it says describe the graphical significance of b. I would say b shrinks the graph, probably both vertically and horizontally. It's like, if I think about this hill right here, that hill is moving more towards the origin. So as b grows, the place where that hill is goes towards 0. Okay. So I would say for part A, as b grows, the maximum value moves towards 0, as does the x-coordinate of the max value. So b seems to be shrinking the graph based on what I see right here. Okay. Now part B says find the coordinates of the critical points and use it to confirm your answer. So when I find the critical points, I need f prime of x. Now this is a product of two things, x times e to the minus bx. So I have to use a product rule. The derivative of the first function times the second function plus the first function times the derivative of the second function. Use a chain rule here to take the derivative of e to the minus bx. So that means I take the derivative of the power times the original exponential, and there you go. Now I am going to simplify this a little bit. Factor out an e to the minus bx, and what I have left is 1 minus bx. The critical points occur when f prime of x equals 0. So that's where 0 equals e to the minus bx, 1 minus bx. So using the zero factor property, I know that the product of these two things being 0 means that e to the minus bx could be 0, and 1 minus bx could possibly be 0. But this function's never 0 no matter what value b is. But over here I can solve for b, or since I want the critical points, I'm solving for x. bx equals 1, x equals 1 over b. Now the question says, use it to confirm your answers to part A. So here, think about this as b gets larger or grows. Can't write grows apparently. Or grows, x goes towards 0, just like I saw in the picture up there. And that's all that is needed for this problem.